Hey everyone, so we're going to go over the participation problem that was given out, I think, last Friday and due today. Anyways, we have a pulley that has some mass 3 we're calling it, and a radius. So when this thing's spinning, we could treat it as a uniform disc or a thin cylinder, is what our moment of inertia table says. Calls it rather. And then we have mass 1 hanging down and mass 2. In the past, we solved this problem without a mass of a pulley, but we're going to consider the mass of a pulley this time, and hopefully that won't make it much more difficult, just a little more algebra. So what I gave you guys to work this problem was 3 equations. We looked at this first one. It was just looking at this mass. We have the force of gravity pulling down on it, mass 1 times gravity, and then we have the tension in the opposite direction. We don't know what T1 is, so we'll just leave it as that for now. And that's going to equal, because we summed our forces, our mass 1 times acceleration. And this is a little different than how we worked it in the past, how we set it up. I normally don't like talking about tension, but I thought it might make it a little more clear than just kind of jumping to conclusions and confusing anyone. So maybe you could build this from the ground up if need be. And so now let's look at what else we have going on. So we'll call this equation 1. And then our second equation here, we are looking at the tension 2, which is upwards. I put it first in positive because it's pointing in a counterclockwise direction. And then minus m2g, which is just the force of gravity on mass 2. And then that's going to be, once again, we summed our forces on mass 2, and that's equal to mass 2 times acceleration, and we'll call this equation 2. And so now considering the pulley, we know a sum of our torques equals the moment of inertia times angular acceleration. And so we had 2 torques, right? We have the tension from 1 and the tension at 2, T1R minus T2R, which comes from this. And then that's going to equal, once again, our moment of inertia times our angular acceleration. Our moment of inertia for our thin cylinder is 1/2 mr squared, and we got our angular acceleration. So using these 3 equations, we have 2 unknowns. We don't know tension 1, we don't know tension 2, but we also don't know angular acceleration. So we could use this relationship to substitute for our angular acceleration in terms of translational acceleration, how fast those boxes are going to be accelerating, and the radius. So let's call these equations 3 and 4. So the first thing I'm going to do is plug equation 4 into equation 3. It's an easy task because all we're doing is substituting our angular acceleration for our translational acceleration divided by our radius. On the left side, I'm just pulling out the r so I don't have to write it twice to save space. And then we got T1 minus T2. And that's going to equal 1/2 mr squared multiplied by alpha over r. And so looking at this problem, the big R and the little r are the same, so I should write it the same. It's just the radius of our, this radius here, the radius of our pulley. And so looking at this, we got an r in the denominator here, and an 2 r's in the numerator here. But we also have another r on the left side of this equation here. So really all of our r's are going to cancel out anyway, so we don't end up even caring about those. This will cancel with one of those, and this will cancel with the other. So what we end up with is T1 minus T2 equals 1/2 MA. Okay. So now we don't know acceleration, we don't know our tension 1, and we don't know tension 2. But what we could do is use equation 1 to solve for tension 1 and equation 2 to solve for tension 2. and plug those into our this new equation that we came up with. So really looking at this, our tension 1 is just going to be the minus M1A minus M1G, because all we're doing is subtracting this, or plus M1G rather. All we're doing is subtracting M1G over and then dividing by that negative. So T1 equals Mg or M1G minus M1A. So let's plug that in for T1. We'll have M1G minus M1A. And then for tension 2, we could go to equation 2 and solve for T2. All we're doing is adding over M2G equals M2A. And then our right side of the equation, we're not changing anything. It's just going to be 1/2 MA. So we could simplify this. We got two terms that are dependent on gravity we could combine, and then we have two terms that are dependent on, or really three terms that are dependent on acceleration. Okay, so when I plugged in T2, I just realized I made a mistake. I didn't distribute this negative sign to both of these. So both of these terms should actually be negative. So let me correct that real quick. Okay, so now we can combine our like terms. We'll just move everything that is dependent on our translational acceleration to the right side of the equation, and then we'll just combine our like terms from gravity. So we could pull gravity out in front here. Oops. And our right side of the equation is all going to be dependent on our acceleration. So we're adding this term and this term over. So we're just going to be left with 1/2 MA plus not MA, sorry, this is M3 plus M1 plus M2. This should have had a 3 here. Okay, so now it should be pretty obvious that we could just divide the left side. We know what mass 1 and mass 2 in gravity are, so we just need to divide by everything here, and our only unknown is our acceleration. So we get an acceleration equal to G M1 minus M2 divided by 1/2 M3 plus M1 plus M2. And so we know the mass of all three of these, and we know what gravity is. So everything in this equation, we know our known values. So we could just go ahead and plug everything in. I'm not going to write the units just because I'm not that great at writing with this. So we got gravity, 9.81 meters per second squared. We got mass 1, 5 kilograms minus mass 2, 25 kilograms. And then the denominator, we got 1/2 mass 3, which was 10 kilograms, plus our mass 1, 5 kilograms, plus mass 2, 25 kilograms. And of course, the left side of the equation shouldn't be gravity. This is acceleration. Okay, so we plug that in, and this comes out to be a negative 5.61 meters per second squared. And looking at this, the negative comes from because of how we define which direction we're going in. We said if it's going clockwise, that it's going to be negative, and if it's going counterclockwise, it's going to be positive. Well, looking at these masses from the get-go, mass 2 is much larger than mass 1. So we figured we could assume that this is going, if it's going to spin at all, it's going, and since we have no friction, it will spin, but it's going to spin in a clockwise direction. So we get a negative value for our answer. So if we are going to give this a direction, as we should, it's going to be negative 5.61 in the y-hat direction. So everyone that turned it in did pretty good. I'm not too worried about that. Hopefully it made sense to you guys. If you have any troubles, or if you're having trouble with this, let me know. Or if I made a mistake in the video, also let me know. But my answer was matched several other students, so this should be the correct answer. All right. I guess that's it. I'll be posting another video soon. Take care.